Hi everyone, welcome to Pi Academy. Today we're going to be doing the 2025 AMC10A Problem 11. So the sequence 1, X, Y, Z is arithmetic. The sequence 1, P, Q, Z is geometric. Both sequences are strictly increasing and contain only integers, and Z is as small as possible. What is the value of X plus Y plus Z plus P plus Q? Well, let's take a look at both our sequences here. So we have one sequence being 1 X, Y, Z. And we have another sequence being 1 P, Q, Z. So let's see what we can use. Well, we know 1 X, Y, Z is arithmetic. And we know in an arithmetic sequence, there is a common difference between the terms. Let's set this difference to be A. If the difference is A, then that means X must be 1 plus A. That means Y must be 1 plus 2A, and Z must be 1 plus 3A. So let's write that down. Z is equal to 1 plus 3A. We can use this information because there is Z in both sequences. Now let's see the geometric sequence. We know geometric sequences also have a common factor in them, like it will increase by the same factor each time. Let's set this factor to be, for example, D. Then P would be 1 times D, which is D, Q would be D squared, and Z would be D cubed. So Z is equal to D cubed. Because they both have Z, we can just set 1 plus 3A is equal to D cubed. And we want to find the smallest value of Z. That would mean we want to minimize A and D. But the thing is, this sequence in both sequences have to be strictly increasing. That means both A has to be positive and D cannot be fractional. So let's use that. Let's try some numbers. Let's try D is equal to 1. If D is equal to 1, then 1 plus 3A is equal to 1. So then A would be equal to 0. Is that our smallest value? Notice that when A is equal to 0, the sequence isn't increasing, because if A is equal to 0, X is 1, Y is 1, and Z is 1. That isn't increasing. They're all just 1. So this doesn't work. Let's take the case where D is equal to 2. So 1 plus 3A is equal to 8. So 3A is equal to 7. That doesn't give us an integer value for A. So that doesn't work either. Let's try D is equal to 3. So 3 squared is 27. So 1 plus 3A is equal to 27. So 3A is equal to 26. 26 isn't divisible by 3, so that doesn't give us an integer value of A either. Let's try D is equal to 4. Then D cubed would be 64. And that's equal to 1 plus 3A. So 3A would be 63, so A is equal to 21. That's an integer value. So we have A is equal to 21 and D is equal to 4. Is that what the question's asking us? The question asks what is X plus Y plus Z plus P plus Q. So let's find these. Well, let's take a look at our sequences here. We have 1 X, Y, Z. Let's find the value of each. Well, we know A is just 21. So 1 plus A would be X, and that's 22. Y is 43. And Z is 64. Let's take a look at 1PQZ. We have 1PQZ. The common factor here is 4. So we would have 1, 4, 16, 64. These are our two sequences. Now let's take a sum of X plus Y plus Z plus P plus Q. So this is X, this is Y, this is Z, this is P, and this is Q. Let's add them. We know 4 plus 16 is 20. We know 22 plus 43 is 65. And then let's take 65 plus 20. That's 85. Now we take 85 plus 64, and that is 149. So our answer is 149. And that leads us to that would get us our answer. Today we're going to be doing the 2025 AMC10A Problem 12. So Carlos uses a 4-digit passcode to unlock his computer. In his passcode, exactly one digit is even, exactly one, possibly different, digit is prime, and no digit is 0. How many 4-digit passcodes satisfy these conditions? Well, let's take a closer look at the conditions. If exactly one digit is even, what are the choices? Let's look at the even digits. Well, it can't be 0 because there's no 0. So it'd be 2, 4, 6, or 8. And exactly one prime. That would be 2, 3, 5, or 7. Well, one thing we can notice is there's 2. 2 is both even and prime. We have to take that into consideration later. And how many digits are neither prime nor even? Well, 1 and 9. So let's take a look. If 2 is both even and prime, we can't have 2 be the even, or else there would be more than one prime. So let's take this into two cases. In case 1, we have a 2. And in case 2, there is no 2. So in case 1, if we have a 2, then that satisfies there's only one prime and there's only one even. So if we have a 2, we could put it in 4 different spots. And for the other 3 spots, we can either choose 1 or 9. So that would be 2 cubed. Because this has 2 choices, this has 2 choices, and this has 2 choices. So this has a total of 32 choices. Now we have to take case 2, where there's no 2. So we have our 4 digits, and besides the 2, there are 3 evens. So there are 3 ways we can choose an even number. And besides the 2 in the primes, there's also 3 ways we could choose a prime. Now we have to see how many ways are there to choose a 1 or a 9. Well, let's see. If we already chose an even and we already chose a prime, how many ways are there to order it? Well, we know, let's say we chose the even, and there are 4 ways to place down the even. So we will have 4 times 3. And say we have 3 choices for the prime. Say the even's already here, then we only have 3 choices to where the prime is put. Now we have these 2 places left. Now we can choose either 1 or 9. So we have 2 squared here. And now let's simplify it. We know this is 12, this is 9, and that's 4. So basically what we have here is 36 times 12. 3 times 144. We can do the multiplication here. 144 times 3 is 432. 432 cases for case 2. And let's take the sum of case 1 and case 2 to find the total number of possibilities. And that'd be 464. So let's take a look at our answer choices, which gets us answer choice D.
Hello guys, we're going over the 2025 AMC10A Problem 13. So the outside square considers infinitely many squares, each of them with the same center and sides parallel to the outside square. The ratio of the side length of a square to the side length of an index inner square is k. And so basically the area of the shaded portion is 64% of the area of the original square. What is k? So basically, let's say the outside square has side length 1. Then the inside square is k, the inner square is k squared, and the inner square is k cubed. So then the areas are 1, k to the k squared, k to the 4th, and k to the 6th. So now what is the shaded area? The shaded area is 1 minus k squared plus k to the 4th minus k to the 6th plus all the way down. And so this is just an infinite geometric sequence. This is just 1 over 1 plus k squared. And this is equal to 64 over 100. So now cross multiplication gives us 100 equals 64 plus 64k squared. And now this yields k squared is equal to 9 over 16, or k is equal to 3/4. So thank you guys for watching.
Today we're going to be doing the 2025 AMC10A Problem 14. So 6 chairs are arranged around a round table. 2 students and 2 teachers randomly select 4 of the chairs to sit in. What is the probability that the 2 students will sit in 2 adjacent chairs and the 2 teachers will also sit in 2 adjacent chairs? Well, let's see. Something special about this question is it says they are arranged around a round table. What's special about a round table? Well, in a round table, you can rotate the seats and rotate the seating. So the key idea here is, say we have 6 seats. 1, 2, 3, 4, 5, 6. We have to put one student or one teacher down to anchor the table. So let's have S1 be student 1, S2 be student 2, T1 be teacher 1, and T2 be teacher 2. So let's just put S1 right here to anchor the table down. It doesn't really matter that we put S1 here, because S1 being here versus there, it all doesn't matter. Now that we've anchored down the round table, now it matters that either someone's to the right of S1 or someone's to the left. Now the order does matter. So that's the key part to doing this problem. So now we want the total ways that we can sit everyone down. So the total ways we can have S2, there are 5 choices. 1, 2, 3, 4, 5. So we have 5 choices for S2. And likewise, once S2 sits down, there are 4 choices left for T1 and T2. Once T1 sits down, there are 3 choices left for T2. So the total number of ways we can sit them down is 60, because we multiplied them. But now we want to find how many ways are there that the 2 students will sit next to each other and the 2 teachers will also sit next to each other. Well, if we want student 1 and student 2 to sit together, there are 2 choices for where S2 can sit, either to the left or to the right of student 1. So there are 2 choices. Say let's sit S2 right here. Now we want to find how many ways S1 and S2 can sit together. Well, this is kind of tricky, but one way we can think about this is, let's make sure T1 and T2 always sit together. So let's consider T1 and T2 as a big block. So we can either sit the block here, here, or here in order for them to be next to each other. So there are 3 ways. So T1 and T2, there are 3 ways. But notice we can also change the order. It can be T1, T2, or it could be T2, T1. So we have to multiply this by 2. So there are 6 choices here. So let's take these 2 and we multiply them. So there are 12 choices, or 12 ways we can seat them. So S1 and S2 sit together and T1 and T2 sit together. So if we take 12 ways that satisfy our conditions over the total number of ways, which is 60, we get 1/5. So 1/5 of the time the students sit together and the teachers sit together too. So that gives us answer choice B. Today we're going to be doing the 2025 AMC10A Problem 15. So in the figure below, ABEF is a rectangle. AD is perpendicular to DE. AF is equal to 7, AB is equal to 1, and AD is equal to 5. What is the area of triangle ABC? So at first, looking at this might be pretty difficult, because how are we supposed to find that? Well, let's write down what we know. So we know AF is 7, and we know AB is 1, and we know AD here is 5. And we want to find the area of ABC. Well, we know this is a right angle because it's part of a rectangle. So if this is a right angle, we know if we find BC, we can find the area because it'd be the height multiplied by a base. So let's set BC as x. Using Pythagorean theorem, we can find AC. Let's write it over here. Say AC would be the hypotenuse. So using Pythagorean theorem, the square root of AC would be the square root of 1 squared plus BC squared. And BC is x, so it would be 1 plus x squared. So that's AC. Then using AD is 5, we can find CD. CD would just be 5 minus root 1 plus x squared. Well, what else can we use? We know EB is also 7 because AF is equal to BE because it's a rectangle. So, if BE is 7, what is EC? Well, you minus x because BC is x. So, EC would be 7 minus x. So, what can we do now? Let's clear up our graph here so it's a little more clear. So, we want to find what BC is. We want to find x. Well, what's something we can use? Notice that this is a right triangle and this is also a right triangle. So, can we use similar triangles? Well, let's take a look at triangle ABC. Is this similar to anything? Well, we know ECD, this angle, is equal to ACB because they're at an intersection point. Using AAA similarity, we can find that ABC is similar to this here, is similar to triangle EDC. And how can we use this to help us? Well, let's create a ratio of the side lengths that we do know. Well, DC here is, or CD here is 5 minus root 1 plus x squared. We can take this length, right here. If we take this length over EC, which is a hypotenuse, EC is 7 minus x. The ratio of these side lengths, let's take a different color here. The ratio of these side lengths should be the same as the ratio of CB to AC. Well, what's CB? CB here we have is x over CA, AC, which we set as 1 plus x squared. Perfect. Now we have an equation to solve for x. Now let's solve. Let's take cross multiplication to simplify it. So we have x times 7 minus x is equal to root 1 plus x squared times 5 minus root 1 plus x squared. Let's distribute on both sides. So we have 7x minus x squared is equal to 5 root 1 plus x squared minus 1 plus x squared. Well, technically it'd be that. So notice that we have negative x squared on both sides of the equation. So why don't we just add x squared on both sides? So we have 7x is equal to 5 root 1 plus x squared minus 1. This is a lot simpler, but let's take the square on both sides so that we can get rid of the square root. So let's first move the 1 over here, and now let's square both sides. So if we square this, and we square this. 7x plus 1 squared is 49x squared plus 14x plus 1. Let's square this side, so it's 25 times 1 plus x squared. Let's distribute the 25, so we have 49x squared plus 14x plus 1 is equal to 25 plus 25x squared. Well, this is just a quadratic equation. Let's move everything to one side to keep it clear. We have 24x squared plus 14x minus 24 is equal to 0. Well, let's clear up some space here so we can solve this quadratic. So, once we clear this up, let's factorize our quadratic here to help us simplify. Well, we can factorize. First, why don't we divide by 2 on both sides of the equation to keep it easy. So 12x squared plus 7x minus 12 is equal to 0. Well, how can we factorize this? There's many ways we can solve this quadratic equation, but since we can factor, let's try this first. Well, if you didn't notice, this should be the factorization, because negative 3 times 4 is negative 12, and the other terms will add up to 7x. So if we solve this, x is either equal to negative 4 over 3 or 3 over 4. Well, we know x can't be negative because we're working in geometry and it can't have a negative length. So x is 3/4. Is that our answer? Well, no, we're trying to find the area of ABC. Now we have AB is 1. 1 times 3/4 over 2 to find the area is 3 over 8. So our area is 3 over 8, which gives us answer choice A,